Коллеги, всем доброе утро. Спасибо, что подключились к
Good morning,
нашему...
dear colleagues, and thank you for joining our today's webinar. A few words before we begin. So today this session is provided with the simultaneous interpretation from English into Russian. So you can find the relevant button, the globe button at the bottom bar of the screen. So hit that button and then choose the relevant language that you need. Our colleagues from Vectra will be talking in English today. So there is no need to waste any more time. So I think that we can get started, and those who will be late will just join us. Should you have any questions, pull them into the chat or into the comment box, and we will do our best in order to answer them during the presentation or after the presentation. So first, we're going to have some theoretical part, and then we will definitely show you the demonstration, how Vectra works, and you will be able to ask your questions. So if you can compare this solution to any other solutions like Stealth Watch, we will be more than happy then compare Vectra to other solutions and to show you why Vectra NDR is much better than other solutions available on the market. And first, I would like to give the floor to Teppo. Teppo, over to you.
Okay, now I'm unmuted. Hey, thank you, Andre, and welcome to this session. Thanks for joining. So my name is Teppo Halonen, and I'm the regional director for the Northern Europe in Vectra. And with me, I have Rudy Jager, who is our security engineer, who is going to be focusing on the demo part, and Tommy Tarpio, who is our regional partner manager. So I know that we have some partners here on the call, as well as companies that might be considering a solution like Vectra. So the agenda for today's session is looking like this. So we'll start to talk about a little bit about ransomware, because it's been a very, very hot topic lately, especially the year 2021 was, I guess, a year of ransomware in the cyber. We saw a lot of, let's say, evolutions there, and Vectra has been helping our customers to prevent these ransomware attacks from doing damage. Then after that, we'll go into a little bit of an overview of what Vectra actually is and what it does, followed by a demonstration, and then finally we'll look at this a little bit from a, let's say, market point of view. What does the Russian market look like for solutions like this? And also, as Andre alluded to, so a little bit of a comparison. Stealth Watch has been deployed in Russia to some extent in some customers, so we'll show a little bit what the key differences there are. But without longer intros here, I'm going to jump into the ransomware section. So I think a lot of you obviously know this, but we've gone through like a 20-year cycle of like development and evolution on the what ransomware is. It started with these kind of I guess script kiddies, people who wanted to show that they can do something nasty, developing these kind of scareware things that were a nuisance, but didn't always have a big business disruption impact, which then evolved into some of these larger or things that led to larger breaches. There were large companies hit in the 2010 period with ransomware attacks that led to hundreds of millions of write-offs and a lot of downtime. But they were still like isolated packages or isolated incidents. Specific ransomware strain got released, and it wreaked chaos globally. But now in 2020, what we started to see is that this became a business. So over the last decade, I think there's a couple of things that have happened. One is that the tooling that hackers and the threat actors out there has developed, and there's a lot of like open source tooling available. And then at the same time, we've got the cryptocurrencies that are enabling kind of the monetization of ransomware. So now we're seeing a totally different landscape where they're very organized players running these ransomware shakedown operations and ransomware crime. So the four groups that we are seeing most in our customers, we're serving today only about 700 to 1,000 customers worldwide. But in that base of customers that we have, the four highlighted here, DarkSide, Revil, Conti, and Mace, are the ones where we have seen most occurrences of out there in the wild. And what's new with these things? What is different from the past is basically the fact that this has become a business. It's an organized business that is happening. There are obviously kind of a lot of different strains out there also, but there are a couple of ones like Conti and DarkSide leading the pack there in terms of how much ransom money they are raising through their operations. So it's $1 billion industry already today. And how these guys operate is basically a almost like a ransomware as a service business model. So there's this group, we're using DarkSide here as an example, an organized group of hackers who've been putting together a toolkit, a platform, if you like, that is containing all the tooling as well as the instructions how to use it, and for performing that ransomware attack and also collecting the ransom and then also supporting the recovery operation after the ransom is paid. And these guys, the DarkSides and the Contis and the Mace, they operate and they run, they have the technology, but then they're working through an affiliate network. So people who are able to gain access to an enterprise or an organization, a target organization, who are able to kind of initiate the attack, gain the initial foothold into the organization, they can reach out to DarkSide and they can become an affiliate, and they just need to prove that they have the access and they can perpetrate the attack, and they run a revenue sharing model between themselves. So DarkSide being the platform provider, and then the affiliates being the perpetrators who gain access. And that's really the scary part of this, as we're seeing a lot of this activity where there are potentially even malicious insiders, so employees of companies who might become affiliates and open the door for the criminals to get in. And also the other aspect here is the double ransom side of the thing. So typically in the good old days, the ransom demand was basically for getting the access to the decryption keys to be able to restore the environment. These are for the vast majority a double ransom demand, where the demand is not only for decryption but also avoiding the release of the data. So the ransomware networks like DarkSide, they're also exfiltrating the data, and they're threatening not only with the encryption but also with the release of the confidential data out there, which makes it even more compelling for the end user to actually pay up. So then if we look at this from a, let's say, a little bit more technical point of view, because ransomware is just one of the threats out there that Vectra is helping to protect against. But the interesting thing for us is that, and for security professionals, is that there's actually here with the ransomwares of today, there's actually very little new from the technical point of view. The kill chain, if you're familiar with the term kill chain that Lockheed Martin branded, which is describing the steps of the attack to reach the objective. are pretty much the same as we've used to seeing in all of the cyber attacks that are out there. It all starts with gaining that initial foothold into the target system. The perpetrator needs to get access to some machine within the environment, establish some sort of a command and control connection. The initial access could happen through exploiting a vulnerability, or it could be through phishing or social engineering to gain valid credentials. And then it progresses towards a reconnaissance phase. So some of these ransomware things are remotely operated, some of them are automated, but nonetheless, they always perform some kind of reconnaissance within the environment to understand where the high value assets are, and they work to discover where the important data and applications reside. And they try to escalate their privileges and move laterally within the environment towards the high value targets, which in ransomware cases typically data. And then finally, it's the move towards the action on the objectives. And in these ransomware cases, it's primarily exfiltration of the high value data for basically for the purpose of threatening to release it. And then also encryption of the data. And the interesting thing really, as I mentioned here, is that the techniques, tactics, and procedures, the TTPs, for all of these ransomware operators there are still the same as they always used to be. So for Vectra's point of view, because we're looking at behavior, attacker behavior on the network, we have, for instance, had not to change anything in our systems in order to detect the behaviors of these ransomwares in the customer environments. Also for the exfiltrations, still very standard TTPs, and the only unique part from a ransomware is really the final kind of decryption or encryption procedure there. So from Vectra's point of view, a ransomware attack looks very, very similar to an APT group, a nation state actor, or a sophisticated hacker penetrating a customer environment. And of course, the objective for the enterprise and the organization, the target organization, is number one, of course, to try and stop anything like this happening. But then sometimes that is not successful, and the only recourse there is to be able to detect the attack early on to stop it from becoming a breach. So I'll show an example. This is it says a few weeks, but this is actually already, I think, 6-7 weeks old. It's a manufacturing company in Switzerland who was hit. If I remember right, this was Conti. So what happened there, well, how the attack unfolded, was basically that there was a fair amount of external reconnaissance. So it wasn't a malicious insider, it was an external party probing to find a way in to get into the environment. And in this case, they found a vulnerability on the Sonic Wall VPN, which they were managing to exploit and gain a foothold into the environment. That reconnaissance activity was going on for about 6 days. Vectra didn't really raise any alert about that, but afterwards, when we went to the incident response, we were able to see clearly what kind of reconnaissance there had been performed. But then after that initial implant was put into the environment through getting access to this vulnerability, certain things were done, some scanning behaviors, some external tool loading into the environment to crack more credentials, which happened pretty much right after the exploit was utilized. At that point of time, Vectra detected the scanning behavior. We raised detections on port sweeps, RPC reconnaissance, and a few other behaviors that we saw in the system. And then over a period of 6 hours, there were more detections when the lateral movement started to progress. and the perpetrator was able to crack credentials, so find credential in the system on one of the machines to get towards the domain controller, and that happened pretty much 7 hours later than the initial compromise happened. And at that point of time, we basically had already seen enough. So our systems, our AI basically said that this looks pretty bad, and the customer had enabled some automated response capabilities. So our certainty level of the attack being a true positive went up to a level where Vectra basically said that it's time to block this. So we triggered a message towards the EDR system to block those hosts that were compromised out of the system, and the attack was prevented. So that's just one example. We've seen multiple of these over the past couple of months. In this case, it was starting from a vulnerability. We've also seen where remote working employees have been compromised at their homes, and the attack has started to unfold from there. But still, nonetheless, all the time we're seeing the same pattern of behavior post compromise that we're consistently pretty well able to detect. So we'll be glad to talk more about ransomware as we go, but as we want to cover a little bit of ground here, to also share more about Vectra and get to the demo, I'm going to switch gears here and tell you a little bit more in detail what Vectra really is, because we're obviously not a very well-known brand on the Russian market, but hope to be that in the months and years to come. So we're as a company, we're about 10-year-old company out of the United States, out of Silicon Valley, founded in the Bay Area, and the company came to be with the idea that maybe attacks can be cyber attacks can be detected in the network traffic by applying machine learning and AI to find the pattern of the attacker behavior, because we started to understand already back then that signatures and indicators of compromise, IOCs, are something that is changing all the time, and more the attacks are always like 0 day. The signatures don't match, the IOCs are changing, but the behavior is pretty immutable on the network. So that was the idea, that was the hypothesis where the company was founded, and it turned out to be a true hypothesis. So it really seems possible, and it is possible to find the needle in the haystack using machine learning to detect attacker behaviors. So we've had the same focus from the beginning. Today we have, like I said, 700 to 1,000 customers. I'm not keeping track fully. We're operating globally. Pretty much half of the Vectra business is in Europe and Asia. Half of it is in the United States. We're servicing governments. We're servicing enterprises, retailers, manufacturers, utilities, oil and gas, schools, banks, so all industries. So the common denominator in the Vectra customer base is it's companies who take security seriously. They've realized that stopping every breach or every compromise is not possible, and they've taken an assume compromise approach to their security. So they assume that a compromise will happen at some point of time, and therefore detecting it and responding to it in a timely manner and in an automated way is key. So really where we play, if you look at the NIST framework, it's the detect and respond swim lanes of the NIST framework. That's our focus. Our coverage from an attack surface point of view covers all of the modern hybrid enterprise attack surface, starting from the IoT, OT, to the campuses, to the offices, home offices, to the data center, LAN, WAN, as well as the cloud in all its formats, IaaS, SaaS, and PaaS. So that's the attack surface that we're doing this detect and respond on. and the types of threats and risks that we're working to prevent and detect are these types of malicious actors, APT groups, cyber criminals, malicious insiders, ransomware. I guess the only thing that we don't really kind of focus on is denial of service. That's not our thing. We're working post-compromise, and the attacker objectives are many. So all of that is something that we see. So that's the Vectra scope. This is where we play. And then if you put Vectra into the context of the cyber security technology ecosystem, so our box or our slot in that cyber ecosystem is what Gartner calls NDR, network detection and response, where the N is really a little bit more than the traditional TCP, IP, LAN, and WAN. It's the hybrid network. So I guess the SOC visibility triad starts to be a pretty well accepted and adopted concept. It was launched by Gartner in 2019. And the idea here is that when we talk about detection of attacks and responding to attacks, there are two primary ways of doing that. You can do that on the endpoint and you can do that on the network. The capabilities to detect an attack from an EDR solution point of view, endpoint detection and response solutions point of view, is covering part of the attacker behaviors, and the rest of the attacker behaviors is covered by the network detection and response. So on the endpoint, the EDR solutions are the evolution of antivirus, where antivirus was very signature focused and EDR is much more behavior focused. And then on the networking side, I think the NDR solutions, you could think of them as the evolution of the IDS or network traffic analysis solutions that evolved then to these NDR platforms like Vectra of today, where the focus is on behavior. The role of the SIM in this triad is a little bit shifting. SIM was never, people have tried to use SIM as the detection platform, but it was never great for that. But the role of the SIM, as we see it, is shifting as we're bringing with EDR and NDR, we're bringing the analytics closer to the source of where the action happens on the network and the endpoint. So now the role of the SIM is shifting towards being the place where the detections that come from EDR and NDR are correlated. They're dashboarded. It's the first pane of glass for the security analyst, from which he can pivot then to do the analysis in the EDR or NDR system. The SIM brings the workflow, starting to move towards the SOAR things. So when our customers are adopting Vectra and endpoint detection response solutions, the burden of putting data into SIM is getting a little bit less. And the burden of creating use cases in the SIM is getting less because we're bringing the detection closer to the source. And another way to position Vectra is also to look at it from the cyber kill chain point of view. So as said, we're a post-compromise solution. So of course, companies need to do everything possible to prevent the breach or prevent the compromise with firewalls and all of the things that you have in the preventive technology. But then there is this security gap out there today, post-compromise, when the malicious actor has gained foothold into the system and starts to execute the cyber kill chain. There's a big visibility and security gap there today, and really that's what we're trying to cover here, to cover the behaviors and the attack kill chain phases prior to the breach is happening. So that's really our focus. How the platform looks like. It's a little bit busy slide, but in the middle here, our platform is called Cognito. So the platform contains all of the machine learning and analytical algorithms that we've developed. that is basically taking as the input the raw data. So the types of data that we ingest is typically, of course, packets from on-prem and cloud networks through port mirrors or TAP infrastructure, and then in the hypervisor environments, or then in the EAS platforms in the cloud through virtual taps. And then we also leverage logs and APIs when it comes to environments where packets are not available to us. The platform runs the analytics, and we basically provide two types of functionality. So one, let's say 90% of our intellectual property is really in the automated detection. So we have all these purpose-built detection algorithms that are running all the time in real time, looking at that data that comes in from the network. We're taking the network packets, we're creating metadata out of that. If you're familiar with Zeek, so we're creating enriched Zeek formatted metadata out of the network traffic. We're analyzing it, running our algorithms on it, and then we're providing a view of hosts and accounts in a prioritized way based on the observed behaviors on them. So we're scoring every host and account. We're correlating every detection to host and accounts and scoring host and accounts based on our certainty and the observed threat level, and bringing to surface the progression of the attack observed on a given host. And then on the other side, we're providing a view into the raw data as well. So our customers are typically not like day to day looking at the raw data, but then when we discover a situation that is worthwhile investigating in more detail, typically the metadata that we provide is the richest set of and the highest coverage set of data available to investigate what's actually happened in the environment. So think of it as Vectra converting all of the network traffic that we've observed across the enterprise into logs that can be explored and queried. And then on the integration side of it, we pride ourselves with the fact that we're integrating to every relevant technology in the cybersecurity space out there. So the primary integration directions are here that we're integrating with the EDR platforms to perform response activities and rich context. We're integrating to SOAR platforms to drive security orchestration based on our inputs. We can integrate to firewalls and NAC solutions to isolate things from the network from the response point of view. But then most of our large customers are running the SOC triad concept, where they're using a SIEM platform as the first pane of glass. So we can feed the SIEM platform with the detections, the analyzed outcomes of our algorithms, which can then in the SIEM be correlated to other data sources and dashboarded and then used and consumed in a single pane of glass. So that's what the platform looks like. And there's two things I think I'd like you to remember about Vectra. So the number one thing is that Vectra provides a great coverage of all of the tactics, techniques, and procedures that attackers use. So we have a 97% cover of the MITRE ATT&CK framework of all those TTPs that are having any kind of a network aspect to them. So from a cyber kill chain point of view, we've plotted here onto the slide some of our detection families to highlight how we're covering that security gap with the detection algorithms. Where in the detection algorithms, our way of working is based on security research. So we have a team of security researchers that are all the time working to understand what is it that the attacker is doing, what is the behavior, what is he doing, not really analyzing what is the tool, but for instance, what is when somebody is using Cobalt Strike as the C2 mechanism. So what does that command and control mechanism look like? on the network, and then we have a group of data scientists who are codifying this, creating the right features into the data set to run machine learning algorithms on it. And we're leveraging always the right types of algorithms. We have supervised algorithms that are pre-trained by Vectra on a rich sample data set. And then we have unsupervised algorithms that are learning and baselining all the time in the customer environment, such as the privileged access analytics, where we're all the time baselining that what is normal and what is anomalous. And we leverage deep learning, meaning neural networks, because those are great for pattern detection or pattern recognition problems, the same algorithms that you would use for image and pattern recognition in graphics, for instance, detecting pictures or images. We use the same algorithms to detect attacker behavior out of the network data set. So the outcome of what we do there is basically, I think, summarized here. So we've got a large customer in the UAE. So what they basically say, and this is a pretty consistent feedback from a lot of them. So before they deployed Vectra roughly 4 years ago, they never found the red team. Then when they ran a red team penetration testing exercise, they never found them. But since they deployed Vectra, they said that Vectra is today the only tool that is consistently, every time they have their bi-yearly red team activity, Vectra is always detecting it. Sometimes they also find the detection in some of their other tools like EDR, but the consistent thing is that Vectra is detecting it every time. So the point I'm making is that Vectra is great at detecting true positives. And the other side of it is that a lot of the time the security operations team is flooded with noise. They are flooded with false positive alarms with very little context around them that are very hard to understand or very hard to make sense of, whether it's a bad thing or whether it's just normal. So here's an example. So the point I'm making is basically that Vectra is great at filtering out the noise. And this is an example from a customer environment with roughly 200,000 hosts in the environment. And over a period of 30 days, we had in that environment roughly 30,000 events. That would be typically what you would see in a SIM environment as events to analyze. Out of those events, we filtered out the benign ones, which led to roughly 1,000 detections, which we correlated to hosts and accounts. So in this case, it's the host view, which led to roughly 700 detections, which we further then score based on criticality. Because a lot of the time it's still, even if it looks like attacker behavior, it's still a benign. It might be IT service, it might be vulnerability scanning, might be some legitimate remote access tools. So based on the set of behaviors that we've seen there, we scored them, and eventually we gave the security analyst team roughly 90 detections on that base of hosts over a period of 30 days to actually investigate, which is a pretty high factor of noise reductions. So the AI-based scoring here is really automating the tier 1 analyst workflow. And I guess the point that I was driving there is summarized here. So this is what we hear from customers, and this is what we see in POCs. So we really reduce the amount of noise and give high fidelity detections with rich set of context for the analyst to understand that what has actually happened, what has been the progression of the attack in the environment, so that they have an easier time deciding where to spend their time. And just briefly on the how Vectra fits into an environment. So you would here, I guess, see the modern hybrid enterprise setup. We normally, our solution consists of two sort of physical or virtual elements. So one is the brain. That's the central unit that does all the all the heavy number crunching. So that is typically deployed in a data center as a physical or virtual appliance, or it can be also run in an EAS environment in the cloud. And then we instrument the network with sensors that can be hardware-based or can be software-based. So we typically instrument the data center. We would probably typically instrument some of the larger sites. Some customers also go to smaller sites with the sensors. It's not necessarily always needed. We can instrument the EAS environments with virtual sensors, and then we can also instrument the SaaS services with cloud sensors, as well as the control planes. Currently, we're only supporting AWS, but the plan is to also include support for Azure and then GCP control planes. And the sensors are basically the place where we're capturing the original data, condensing that to the metadata, feeding that back to the brain for analytics, deduplication, and running our algorithms. So if we see 100 units of network traffic originally at the sensors, we condense that to roughly 0.5% of the original traffic into that metadata, feed it to the brain, and make it available for our algorithms as well as the incident responders. So that's what the high-level architecture looks like. So I can't see if there are any questions, or I'll check if I can see if there are any questions on the chat here. I guess not. So that's where I'll pause here and hand over to Rudy to jump into a demo, and after the demo, we're going to look at a little bit the market opportunity with Vectra and what the high level kind of comparison to some other ones looks like. Rudy, over to you.
Thank you, Teppo. Good morning, good afternoon. Yes, so now you should be able to see my application, correct, Teppo?
Yes.
Okay, great. So I will give you a brief overview of our platform. This is our demo environment. In this environment, you see the dashboard. The dashboard contains of several parts of information with detection from the platform. Most important here is the host security summary, and that's where we go in more depth. Below you see an overview of detections on your key assets, worst offenders, hosts, and accounts. And on the right side, you see a breakdown of all the detections in the platform. If I click on the host page, I will see this overview. And Teppo already showed you the 4 quadrants: low, medium, high, and critical. Every host and account is being with a detection is being put on this quadrant based on a scoring. The scoring is based on threat on the left side, uncertainty on the below side, and a combination of the scoring determines whether an investigation is required. We typically advise our customers to look at high and critical. That means that there is an insider threat or an external adversary being active in the network. You can drill down several levels here. So if I click on a host, I can see the specific host name, some identification about the host, the score of this individual host, and I can also see what are the last active detections on this host. The detection models work as follows. So each detection model has its individual scoring, and that individual scoring of all those detection models attribute to the scoring of the host. In this example, I will show you the domain controller where we have seen malicious activities. Domain controller is situated here in the critical quadrant. And when I click on it, I go to this screen. In this screen, I get more information about the host, so the individual score, also observed privilege, maybe some roles we have discovered here, and each role, each host gets a profile assigned. In this case, external adversary, and that is because of the positive indicators we had on this host. I can also go into more details, so I can see what other information we have observed of the host based on the network data. And so we see activity on accounts, activity on services, and some other artifacts we learned from DHCP in this case. If I go back to detections, I see that the first infection on this host started with the HTTPS tunnel, and I can go into more detail there. And this HTTPS tunnel is a detection based on supervised machine learning, and it detected that on this encrypted channel, which we do not decrypt, so we can detect attacker behavior on this encrypted channel based on the behavior of the network traffic and the interaction with the target. And in this case, it appears that this host is being under control by an external destination. And that's typically something what happens with ransomware, that an attacker gets a foothold in a network and starts exploring the networks. So we don't know what this destination is, but we know it's malicious communication. And if I go back to the host page, I see also other activity happened on the host. So I see reconnaissance activity, lateral movement activity on the host. And so it looked like attacker came in and was able to scan the network and is searching for data on the network. If I then go into the other one of the other detections, in this case file share enumeration, I can see that the attacker had access to certain file shares, and also can see which accounts were being used and which shares being targeted. So this is the detection engine of Vectra, but like Teppo explained, that we are getting network data and creating metadata of that network data. We can also do further investigations in the metadata, and that is with Recall, our data lake platform, but it's also available in an on-premise product with your own data lake. In this case, I go to the data lake to find more information about that, and I have access to several types of metadata. And so the most important thing here is the metadata I session. There you can see all TCP and UDP sessions on the network. So that's typically the first thing you go to see what connections were made to the host, to see if there are other suspicious activities. And we also have metadata available on other different types of protocols. And in this case, I selected SMB files because I wanted to see what the attacker exactly did accessing those file servers. And you can see here a simple view of the metadata. There's a lot of technical details below it, just that you know it's available. But what you see here is the attacker had access via SMB version 2 on a share and had access to certain files on this share. In this case, in this example, secret.zip. And so we now know what type of information the attacker was able to gather. So this is mainly used for further investigation after the detection platform gives an alert. Because we have all the metadata available, we also provide a security assessment dashboard that's available here in dashboards. I can click on the dashboard, and what I see here are a couple of widgets with information about risky operations happening on your network. And we can see that because we have visibility with the Vectra sensors in the network. So to go through these widgets. You see here RDP servers, which are accessible from external IP addresses. And that's of course a risk because that can be targeted by attackers to find any vulnerabilities in these systems and accessing your network. We also see, for example, SMB traffic on the network from public environments, but also SMB servers which are using legacy protocol SMB version 1, which is not secure anymore to use. And so these communications are a risk on your network. As well as we see NetBIOS, management protocols, or weak ciphers. In this case, there's no data, but any protocols with weak ciphers are being used in the environments, which can lead to, for example, a man-in-the-middle attack. And lastly, we see an overview of unencrypted traffic, for example, FTP and Telnet on the network, where there might be any credentials being exposed.
Yeah.
So our platform exists of this detection engine where all the machine learning is happening, and we also offer the rich metadata for further investigations. I want to speak also a bit about how to set up the platform. And so Teppo already explained that we're working with a brain, which is our analytics engine. That's also the interface where I'm accessing it. We also have the ability, we also have the ability to deploy virtual sensors in your environment. So, for example, you can download virtual images for KVM, Hyper-V, VMware, and soon also Nutanix. With that, we can also monitor what's happening on the VMware host in your network. And that's very interesting because then we can see lateral movement between the different virtual machines on the VMware hosts. So it increases the visibility of the platform. You can deploy it by just downloading this OVA file, install it on the VMware host, and create an extra port group on the host where we can listen to the traffic at the VLANs you specify. We also have other external connectors. For example, we have an integration with Active Directory, and that is being used for two things. One is for creating context, so I can see more information about an account, which groups the user is member of, and when the password was changed for the last time, when the user was last logged in. That kind of information I can get from the Active Directory. But I can also perform a response. And I can perform an automated response or a manual response. And what we can do here is I have here the option account lockdown. And so I will be able to lock down an account. And I can show you how that looks like. So if I'm on an account, in this example, Conrad, where malicious activity is happening, I have the ability here to disable account for a certain amount of time. So that's a manual response action. I can also do that automatically. So I have here the ability to configure automated disabling of accounts for a certain amount of time when the scoring of the account is above a certain threshold. And so 75. In this case, that means, and I'm going back to the dashboard, that means that there is a threat, and there are detections on an account or a host, which are happening in the upper right part of the critical quadrant, 75. And then I trust the tool, because multiple malicious activities are being seen, severity is very high, to take an automated action to disable the account. We also have the ability to integrate with EDR systems. Teppo already explained a bit about that. So we have native integration with the EDR tools you see listed here, but we can also work with our REST API for integrations. What we can do here is, again, we can do a host lockdown, which is a manual action, and I will show you how it looks like. So 1 second. So in this case, this host, Piper, has also some malicious activity seen on the host, and there's CrowdStrike EDR installed on this host, but this can be any EDR you saw in the list, and I can perform here a manual action to lock down this host for a certain amount of hours, and that will send a signal to the EDR platform to isolate the host. I can also do that automatically, and similar to what I showed on accounts, I can say here disable the host for a certain amount of hours when the score is above this threshold. So these are the main parts I would like to show you of the platform. Teppo, is there anything you would like to add here I've missed?
No, I think it's good. So so we have a bunch of functionality when it comes to SaaS as well, and obviously 5 Azure AD identities. We didn't drill into that. If anyone is interested, we can take another session on that. But as on the Russian market, these are not as prevalent yet, the Office 365 environments, for instance. So maybe we skip it for now. All right. Hey, Rudy, there was a question on the chat here related to NetFlow. I responded to that briefly, but yeah, this does come up. That is can Vectra leverage NetFlow collected from the network through routers and switches? So do you wanna say something about that?
Yes, of course. So Vectra listens to the raw network data of your infrastructure, and we create our own metadata of that, and that is in broad-seq format, and that is far more enhanced than NetFlow, and so we have more attributes of specific protocols available in our metadata, which we can then use for better threat detection. And so our machine learning algorithms have require, but also have a better insight in the network traffic because we're using a more enhanced model of the NetFlow environment. So typically we do not work with NetFlow, and we create our own metadata using our sensors to get that enriched format of the data.
Indeed. And things like JA3 hashes or SSH hashes, and we're enriching everything with host IDs. So we're always resolving with several different mechanisms the IP addresses to actual hosts' names to support the analyst in his work. So those are the benefits that we see. So our algorithms would not be viable. We could not implement these algorithms based upon NetFlow as an underlying data source. All right. So thanks, Rudy. That was the demo. So as the last piece, I'll just try and give a little bit context here to the market for NDR. So if we look at what Gartner is saying, this is the Security Operations Technology Hype Cycle published by Gartner last summer. So NDR as a category is right now on the rise. So EDR solutions are probably 3 years ahead of NDR category in terms of the adoption, but we're seeing a very good momentum right now. Customers are moving from the legacy IDS solutions on the network towards the behavior-based NDR solutions, where Vectra is the leading provider. And it's a very interesting time for us in Vectra. We're growing quite quickly. In my region, for instance, we've more than doubled the team over the last 9 months, 12 months time, and plan to continue to do that, and hope to be able to grow also on the Russian market. So that's the outside view. And then if we look at kind of a little bit the comparison, so we have a few competitors that we tend to compete with. Cisco used to be a competitor that we bumped into a lot, but in all honesty, Cisco StealthWatch, we've replaced Cisco StealthWatch in a number of customers, but today when we are in competitive situations, it's not, we don't really meet Cisco in Northern Europe, at least. I don't remember any case over the last 1.5 years where Cisco would have been the competitor. And the reasons why we think that is basically like high level summarized here. So the key differences why the Vectra approach is different are basically classified here into 4 baskets. So if you look under the hood, the key thing is that what do you use as your data source? So we use packets and we create the metadata out of that. So that gives us the opportunity to create quite sophisticated detection algorithms because we have a lot of granular underlying data. And Rudy, if you need to step out, so feel free to. I know that you have another meeting, so we'll carry on here with Tommy. And Cisco uses NetFlow. So NetFlow is basically good for understanding that what happened between point A and point B in the network. NetFlow can also be used to see the traffic paths through the network and things like that, but it's not great at going into more detail on what did the communication pattern look like, and we want to understand the communication pattern. So the difference there in the underlying data means that we can do way more meaningful detections and also enable way more meaningful information investigation based on the metadata that Rudy was showing there. From a detection approach point of view, so we rely solely on behavior-based technology, or not solely. So we also can ingest threat intel feeds. We have a curated threat intel feed, and you can plug in your own threat intel feeds, but the primary sort of detection mechanism that we use is this attacker behavior pattern recognition using these machine learning algorithms. So we're looking at behavior using these pattern recognition algorithms instead of rules. So you can think about that like pattern recognition problems kind of computationally are very hard to solve with rules. Or they are impossible to solve with rules. So we get way more effectiveness in the detection and way more fidelity by using these more modern detection algorithms. And that also allows us to reduce the noise to a significant degree. So the feedback that we get that Vectra is a very low noise solution. From a scalability point of view, the algorithms that we use are computationally super effective. We don't use any open source, we built our own. So the machine learning algorithms that we use are very computationally effective, which gives us great scalability. So a single brain can scale up to 300,000 hosts, for instance. We also don't decrypt traffic in flight because we see very little value out of that. We're looking at the communication pattern. We're looking at the header information in the communication rather than trying to decrypt. Because normally, whenever we have a attacker communication on the network. It's anyway encrypted with the attacker keys. And our objective is not to kind of find signatures or hashes within the traffic. Our objective is to identify the behavior. So there's no value for us in decrypting. And then with a solution where decryption is applied, you need way more hardware. You take down the scalability and you bring up the cost. And then from a total cost of ownership point of view, Vectra deployment is very, very simple. So we basically deploy the brain, we deploy a sensor, we connect it to a span port, we can deploy as many sensors as we like. They will automatically be managed by the brain, and when the system is deployed and put in there, it starts to learn. Some of the algorithms are pre-trained; they don't require local learning. Some of them will require up to 2 weeks of learning period to build the baseline, but then they run. So those 150 detection algorithms will run out of the box. The only thing that we need to do manually is typically to triage or suppress some of the known false positives, such as domain controllers or vulnerability scanners or some IT admin remote access tools that manifest attacker-like behaviors. But once that's done, it's typically a 1 or 2 day session to get that triage work completed. So that's like suppressing the known noise. After that, no tuning required, no upkeep required. We're all the time self-learning, self-calibrating. So it requires minimal upkeep, and it doesn't need any rule creation. Customers can create custom rules. For instance, if you wanted to have a rule that I want to have a detection when somebody is talking to this specific external destination, you can set that up in the system, but a lot of our customers don't do any custom rules. We could do custom rules on like detecting log4j type of behaviors. We actually kind of launched some of those because some of our customers were asking for them, but that was just like a signature detection rule. But those are not, it's not necessary to work with those because we're looking at the behavior. For us, log4j, for instance, was not a big deal because we of course could show that, okay, here we see exploitation attempts. That's what you have, but we don't see on these target hosts, we don't see any attack progression from them. So nobody has been able to gain foothold. So we work in a little bit different way. So those would be the main differences to competitors such as StealthWatch. And some of the same logic applies to some of the other ones. But in my understanding, most of the competitors that we have are not very active on the Russian market. We mostly see Cisco out there, and we hope to be sort of showing customers the better way with Vectra as we go. So in conclusion, this is basically what we discussed today. So the 5 points, I guess, that you could take away from the session. Number one, we're able to detect attacks that other solutions can't. NDR and Vectra is complementary to IDS and complementary to SIM and EDR. It's replacing IDS systems in the network, and IDSs are typically on the perimeter where we're inside, we see lateral activity. We're providing the best-in-class signal-to-noise ratio in real time and optimizing that detection efficacy. We're reducing the tier 1, tier 2 analyst workload by automating the detection process and applying that scoring that we were showing there on the 4 quadrant, as well as providing rich context about the attack progression and about all the observations that we do. We provide instant time to, number one, full estate coverage as well as productivity. It's a very kind of simple deployment process, and we get a very extensive coverage when we have positioned the sensors in the strategic places in the environment, and we don't leave blind spots into the environment when that's done properly. And we integrate to the rest of the technology ecosystem in the security operations stack. The EDRs, the SIMs, the source, the threat intel, the misfeeds and stuff like that. We can run fully air-gapped. There are no agents to deploy, no decryption of traffic, and yeah, we've been pioneering this AI threat detection space. And MITRE came out with this defend framework on top of the attack framework. So we are the vendor that has the most amount of patents highlighted in that defend framework. So that's speaking to our thought leadership there. But with that, we could go into if there are any questions arising from the presentation or the demo. So open.
Therefore, there are two questions in the chat. So do you have comparison with other NDR solutions like NetScout, Omnis Security? And then there was a question about encryption of the traffic. How about do we encrypt or not?
Yeah, so NetScout, Omnis, we haven't identified them really as a competitor in this space. I would need to come back on that one. So we haven't come across NetScout in any project in Europe, and haven't really heard about that as a potential competitor. Decryption, so I kind of talked about that already, but the point being like HTTPS, command and control channels over HTTPS. So we don't try to decrypt HTTPS. We're observing the communication pattern of the communication with the outside destination and the inside host. And we're looking at how does the communication flow. We're looking at some artifacts there in the headers of the communication, but we're really looking at the pattern rather than the content. So that way we're avoiding the decryption problem, which is helping the customer keep the keys secure. And then fundamentally, the attacker's channel is typically encrypted with his own keys. So he wouldn't be, I mean, that would anyway be not decryptable. So that's our approach. All right. So Andre, do you have any final words here, or
Yes, colleagues, it seems that we have addressed all questions. If you'd like to follow up, you can reach out to us. We'll take your questions gladly. We have a demo station in Russia, so we are able to do testing with you today, tomorrow, together with other NDRs. So we are open for communication. This webinar has been recorded, so you can expect the recordings shortly, both in English and as translated in Russian. So it's going to be available for reference for you to have a recap or to forward this to your customers or whoever might be interested. You'll be able to find it on the NetWall website. Thank you all once again. Thank you for taking the time. And I hope that we'll see you frequently during pilot projects with you and
thank you everyone joining. Have a great day.